Next, I want to go through a couple examples from the textbook. This is example 2 from the textbook. It says, what is the integral of 3x squared divided by square root of x to the third plus 3 and dx? For this type of question, you want to take an integral for it's relatively complicated. You cannot divide by the whole thing into several pieces such that it's exponential, such that it's some kind of polynomial to some exponential, and use the power rule directly because you have a square root on the bottom. But you realize that the derivative of x to the third is 3x squared. That should trigger you to think, oh, maybe I could use a u substitution because I have a portion of the derivative inside, which is like my f of x prime, and also my original f of x. So you want to set u equal to the piece that haven't been taken derivative yet, which is x to the third plus 3. And the du becomes 3x squared, and derivative of 3 is gone, and this is dx. So your original question becomes, this 3x squared and dx, 3x squared and dx is indeed just your du. And on the top is 1, on the bottom is a square root. And your whole thing inside your square root is x to the third plus 3. That is just u. And now your question is simplified into a 1 over square root of u du. And this is something you should be able to handle. That is u to the power. On the bottom is the square root of u is u to the power 1/2. And because it's 1 over, this is u to the power negative 1/2 and du. And then this is just to rewrite my question. Then when you take the integral, you want to raise that by 1. So that becomes a positive 1/2. Of course, you want to have a 2 in front to balance the coefficient so that when you take a derivative, it's gone. And plus c. Again, this is the question. Original question is taking integral respect to x. You should end up with something in terms of x. And now you're having a u. You want to plug whatever your assumption back into the question. So that is 2 x to the third plus 3 to the power of 1/2 plus c. And that's done with that. Okay. Another example will be example 3 from the textbook. It says integral of 4 natural log of x divided by x dx. Okay, again, you will have 2 portions here. You have a natural log of x on the top, natural log one single x on the bottom. If this is example 3. If this is a derivative question, you will need to use the quotient rule to solve this because you have a 2 portion. Now, because it's an integral, there's no such a quotient rule for integrals. Then you want to recognize, is there any connection between the 2 parts of my x or my variable? So on the top is natural log of x. On the bottom is x, which is ln 1 over x. So the derivative of natural log of x is 1 over x. Therefore, I'm going to set the u equals to natural log of x. And the du, which is taking derivative of this, is 1 over x and the dx. Therefore, my original question, I can rewrite it such that it is 4 times natural log of x times 1 over x and the dx. Now, this 2 together is the u, and this is the u. Therefore, the question changed into 4u du, and this is something you possibly able to do this fairly quickly. This will be 4u squared over 2 plus c, or u squared, or just 2 times u squared, or 2 times u squared plus c. Again, plug back in the u you're having, which is 2 natural log of x whole thing squared plus c. Next one, example 4, is what is the integral x plus 1 divided by x squared plus 2x dx. Then for this one, you want to think through the 2 portions. Normally you have a complicated question like this. The top is the derivative of the bottom. This 1 over x is the derivative of ln x. Is one part is the derivative of the other? That's the question you want to think through. Normally the one with the lower degree tend to be the derivative of the higher degree. So the top, you might think that is to do something with the bottom. Therefore, the question becomes, u will be x squared plus 2x. And the du is really 2x plus 2 dx. That is 2 times x plus 1 dx, which is du. But it seems like I don't need this 2. So I'm going to put a 2 on the other side. I only need x plus 1 dx, which is x plus 1 and a dx. Therefore, it's 1/2 du equal to x plus 1 dx. Now I can do the substitutions. That is the integral. And this 2 portion, x plus 1 dx, that actually becomes to 1/2 du. That's what you just calculated in the previous step. Now, down the bottom here is 1 over and 1 over u, because u is defined as x squared plus 2. Now this is what you have. Leave this 1/2 outside. What is the integral of 1 over u? That is actually natural log of L and u. I'm going to put an absolute value just for the courtesy, such that I need to making sure the input is going to be positive. Then plus a c. Then because I defined my u as the polynomial like that, so that is natural log, absolute value, x squared plus 2x plus c. Because this is a polynomial, normally polynomial, while this is defined, if this is defined on the whole number line, there is a chance that this is the negative value. Therefore, put an absolute value in there to make sure natural log is well defined. And this is the final thing. Now, the last example I want to go through is example 5. That is involving with something you see. The previous two, this two, when you get to this step, this is the power rule. This is the power rule. Now, this is more using the natural log rule. Now, I'm giving an example that after you do the substitution, you will use the exponential rule. So the question is integral x squared plus 1 e to the power of x to the third plus 3x plus 1 dx. Then for this question, obviously this is the x squared, this x to the third, this must be something derivative of this. The connection is between these two. So if I'm going to let u equal to x to the third plus 3x plus 1, and your du is going to be 3x squared plus just the 3. And don't forget a dx in there. Now this is very close to this, but you all have a 3 in there. If you factor out the 3, that'll give you 3x squared plus just the 1 dx. And that's what we're looking for. We're looking for x squared plus 1. Then that is du. Now I don't need this 3, so I move that to the other side. So it's 1/3 du equal to x squared plus 1 dx. So that is saying this portion and this portion together will becomes my du, 1/3 of du right here. So my original question becomes e to the power of this all together is defined as u here. Therefore, e to the power of u, and this 2 portion becomes 1/3 of du. And that is, if you pull out this 1/3, is e to the u du, and we know that integral of e to the u, it's just e to the u. And because it's indefinite, a plus c. Now we can plug that u value back in so that we end up with the solution that only having x involved instead of with the artificial variable we created such as u, which is 1/3 e to the power of x to the third plus 3x plus 1, whole thing plus c. And that's all the 3 different types. Example 2 and 3 are similar type. 3 and 4, these are the 3 types of u substitution questions we're going to deal with. Next section, I'll go through some of the practice questions, and see you in the next section.